Hey, welcome back to the series. This is part 4A, Deploy the Ratings API. I'm an Azure administrator as well as Azure Solutions Architect. Hey, welcome everybody back to this lab series. This is part 4. A little recap of what's gone on so far in parts 1 through 3. In the previous lab, we deployed the Mongo database using Helm. That was part 3. We're going to continue our deployment and deploy the Ratings API. The Ratings API is a Node JavaScript application written by using the Express framework. It stores and retrieves items and their ratings in a Mongo database, part 3 of the lab series. We already created an Azure Container Registry instance, part 2 of this lab series. Oh, let me correct that little typo there. Boom. In this part of the lab, we will create a Kubernetes deployment for the RESTful API and create a Kubernetes service to expose RESTful API over the network. A Kubernetes deployment gives you a way to provide declarative updates for pods. You describe the desired state of the workload in the deployment manifest file, or perhaps a YAML file. You can also use JSON, but we're going to use YAML. And use kubectl to submit the manifest to the deployment controller, which is part of the master nodes of Kubernetes. The deployment controller, in turn, actions the desired state of the defined workload. For example, deploy a new pod, which is what we want in this case. You can also increase the pod count or decrease the pod count. We're going to create the manifest file for our Kubernetes deployment called ratings-api-deployment.yaml. You can use the integrated editor in the Cloud Shell or use your favorite editor. I'm going to use Microsoft Code, which is free. If you're going to use the Cloud Shell, just type the word code. You're literally going to type this at the Cloud Shell prompt. Just the way it's written. Code, space, and the name of the file you want to create. In this case, the name of the file you wish to create is called ratings.api.deployment.yaml. And once you do that, your screen is going to look very similar to mine, except it's going to be blank. You won't have these first 4 lines, which we're going to talk about in a second. Now you might be asking, does YAML stand for anything? And it does. It stands for yet another markup language. And this good thing about YAML, you only need to learn 2 types of structures, and that are lists and maps. A map lets you associate name-value pairs. So, for example, kind and deployment would be a map. API version and apps /v1 would be a map. It's very important. Notice the difference in space here. And it's very important in YAML not to use a tab key. Always use the space key. So that's very important. Just notice I got a typo here. Need a G in ratings. Okay, so go ahead and type this in the first 4 lines here. And notice we have 2 spaces and then the ratings.api. Here we have the deployment named ratings.api, and it's indicated by the metadata name. Next thing we want to do is create the Spec Selector, which defines how the deployment finds which pods to. So let's hit the enter key. We've got my cursor back over here. I'm going to go back 2 spaces and create spec, SPEC, enter, 2 spaces, and here's our selector that I just mentioned. and it's got to match labels, and labels are a way to match things up in Kubernetes. Remember, we created the match labels, matchlapels, and the label we want to match is app, and it's called ratings API. Let's go back 2 spaces. So it should be under that S in selector and type template. And then metadata, colon, enter, 2 spaces and labels, colon, app, colon. Here we're going to put ratings API. And here we'll make a little comment line just so we understand what's going on. This is the label for the pods and the deployments. All right, let's go back to under our metadata. And you should have this little line that helps. Here we're going to do spec, colon, and we're going to spec the containers. Name is going to be ratings API. Image, well, where we have that image? Well, we have that image in our Azure private repository. So we have to go get that image name. And let me open up my, well, let me do it this way. It'll be the first one in here. And my registry name is, I should have it saved somewhere. Here it is. And it has a URL associated with it, azure.io/ratings-API version 1. You could have also gotten that information via the portal, if you didn't remember, by going to, I'm in my resource group, and I'm going to go to the container registry. And you see here's the full name. So I might just copy that, minimize this, and just paste it in, just so I don't have a typo. And the ratings-API version 1. Well, where did I get that from? Minimize, minimize. Where did it go? There we go. And I go to, oh, there we go. The word I can't say. Here's ratings-API. Underneath that, we have version 1. So, and you can see here will be the Docker command to pull it. So I could actually just do this, I believe. Copy, minimize, bring up my shell here. Now let's just do that. There we go. This way, pretty confident now that I won't have a typo in my YAML file. Pool policy. I'm going to say always. ports, container ports, 3000, and let's put a little statement here. The application listens to this port. Then environment, env, name, I'm going to say mongodb underscore URI. And we're going to put a little comment section here. The application expects to find the mongodb DB connection details in this environment, env ron environment here. So hit our space. Secret. Remember those secrets. Oh, hold on. Secret key ref. Two spaces, name, Mongo secret, now recall we created this secret reference in the previous lab by this command here. Create the secret called Mongo secret, which should match here, Mongo secret. And of course, this is where we put in the username and password for the secret. So in our manifest deployment file here, we're calling this secret reference. The next step in our YAML file is we're going to reference this key, or this, we're going to reference mono connection. And this is called the key in our YAML file. So don't want a space there. We're going to put key and let's just go grab this so it matches and put in Mongo connection. Whoops. Enter. Now we want under our spec, we want resources. Actually, I should say under our containers for the spec. So it'd be spec, containers, resources. So let's go back to right there. All right, so then we want resources. OURS resources colon requests, two spaces, in requests UESTS requests. And this is interesting. This is where you get to define what resources are needed or limited to your pod. So this is going to set the minimum resources required. REQUIR required. CPU 250 M and memory 64 MI. Limits, which define the maximum that your pod will take up on the node. And maximum resources allocated. And again, you got CPU 500 and memory of 256. Then you have next is the readiness probe, which basically tells, I'm looking for the number sign on my keyboard. Why did I just, oh, there we go. Basically tells, is a container ready to receive traffic? If you remember from when you do, I believe it's kubectl get pods, you see the ready. That's just letting, it's now ready to receive traffic. Did I spell that right? R-E-A-D. Yes, no, I didn't. R-E-A-D-I-N-E-S-S. Readiness probe. Again, that is, is the container ready to receive traffic? And then you define how can we determine if it's ready to receive traffic. And we're going to use just a simple file. Kind of like in the old days, you used like a keep alive. Like when you set up a load balancer, you set up like a keep alive file. So we're going to say we're going to do an HTTP get. And on port 3000. And the path will be health Z. And then we have another type of probe, and there's usually two types of probes you could set. One is it ready to receive traffic? Then once, meaning is it built? And then the liveliness probe, meaning is the probe healthy? I said probe, is the container healthy? I should say, right? So here we're going to use the same test in our example, but they can be different. For example, in the real world, you might want to do a simple check here like we're doing here, but for the probe, you might want to make sure that can the container actually do work. Like you might want to have just instead of a simple page, make it call an application. So you want to make sure that it can actually process the request. But this is good enough for here. And it just remember this is learning, and we're learning about the readiness probe and the liveness probe, what you can do and what the difference is between the two. Okay, if you were using the code or the editor built into the Cloud Shell, your screen probably looks very similar to this. And you should have 3 little ellipses, I believe they're called. You could click on it and click Save, and then close Editor. And you'll be back to the Cloud Shell. All right, what I'm going to do though is, now, oh yes, your file should look very similar to this one. I'm going to do a file save. I'm going to put it in my, I believe I have this in C, users, me, and then ratings. And this is just for me. For you, just if you're doing the code editor, just do the save. I'm going to call it ratings dash API dash deployment dot YAML. Go to here, and I should see it now. Ratings API deployment.yaml, and hopefully that matches what I typed here. Yeah, so looks like we're good. I'm going to clear the screen here, and this is the kubectl command to deploy our ratings app API. So let's give it a try. And this is the feedback you should get. I am getting an error here, as you can see, and that's because to save money, well, this is what I hope it is. To save money, I shut down my pods, or my nodes. So yes, it's trying to create them, and it can't because the nodes are down. So let me go to my resource group here. And scale sets. Instances. You can see they're down. Start them back up. And while that's going, we could also use, let's use this command here where the W is watch. Another command, we'll let that go for a while. It should update. Useful for troubleshooting is logs, and you use the pod name. So the pod name in this case is right here. And then namespace. Well, we're getting some starting happening there. Creating the container. These are 2 good commands for troubleshooting. We'll look at these. If I could learn how to spell. Guess it wants the pod name. And of course the namespace. It looks like we're doing pretty good there. So let's do a Control C. And let's look at our, just right here. And we should see it ready, I believe. We really should see a 1 and 1. So maybe it's still going. All right, so let's take a look at our logs, see what's going on, see if we can see anything. Connect econ refused. This might be from earlier when they were down. That's be my guess. And let's look at this one. So here we got some failed scheduling. It's probably 0 tuners are available. So that means no nodes are available, added 2. And so then we have container ratings, pro failed, the status code of 500. Killing, so this is where it was trying to start again. And then we get a connection refused, and then start to pull the image. Create a container ratings API, successfully pull the image. So let's see how we're doing. Okay, I think I found why it's not working for, well, I'm getting the 0 for 1. So let me show you what I did. I'm going to run this. And it should just say 1 of 1 is ready, right? But it's not. Disappointing. So I run one of my troubleshooting commands, the describe or logs. I'm going to do, I think it's in logs, but let's see. Yes, there we go. You can see it's unable to connect to the MongoDB. And then here's my username and password. Well, if I look back at my working, here is the command where I defined the username, which is good, Speed Racer, password, and look at that, I left out the I here. And then here's when I created the password with the I, and there's no I here. So I'm going to guess I can delete this I, rerun, or let's see. I don't want to reinstall the whole database. So I'm going to recreate my secret to reflect the database. And then redeploy. And I'm hoping that will then fix everything. Now, would it be possible if I just run this? Maybe this will start working. So let's try that. So I'm going to run with the new correct password, update my secret. Now, I have to be honest, I'm not sure if I can update my secret or I have to delete this first. So let's see what happens. So I'm going to run this. Oh, yes, look at that. It already exists. So I'm going to have to delete the secret and recreate it. Okay, I'm back. And I ran the command again. And now you can see it successfully started. You can see I ran the deployment again, 0.1 container creating, and 0.1 running, and now 1 of 1 running. And the way I got this going again was I ran lines 84 through 93. So you can see I added, since my passwords are not matched, on lines 59 and 63. We'll take a look at that. See, XE, oh, well, I fixed it. It was like that. So they didn't match. T-R-I-X-E. Okay, so then came down here. I ran the delete secret. I delete the secret. Then I recreated the secret. Oh, take that out. Hold on. This did not work. So no, that's we're good. Delete the secret. I didn't recreate it. Get rid of that. Then I deleted the ratings app. Then I uninstalled the database. Reinstall the database. Recreate the secret again. And then applied the deployment again. And you can see we're rolling. Okay, so if we run this command here, we'll get the status. And you can see we got 101, it's up to date, and we got one replica available. Okay, this is a good stopping point for the lab. Well, not the lab, but this part of the lab. And next, we will create a Kubernetes service for the ratings API. And if you don't know what a service is, maybe I'm not going to tell you now. Obviously, we'll go into detail about it during that part of this lab series, but maybe do a quick little Google. But thanks for watching, and talk to you guys later.